In this video, we're going to look at permutations where they're identical items. So here's an example. We're going to look at these four words. I use the word in quotation mark, the word words in quotation marks. They're not all words, but they're arrangements of letters. And we're going to look at how many permutations we can have. So for the first one here, the word file, 4 different spots. There are 4 choices for the first letter. It could be an F, an I, or an L, or an E. 3 for the next, 2 for the next, and 1 more. We could list those all out if we wanted to, but knowing about permutations, we know that there would be 4 times 3, which is 12, times 2 is 24, times 1 more is still 24. So there are 24 arrangements of the letters in the word file, 24 different arrangements. If we go on to the word fill now, you might think, well, there are still 4 letters to choose from. And so things might look very similar, but here's what I want you to consider is what happens, let's try that again, what happens if we swap the last 2 letters. So if I take these 2 L's and swap them around, the arrangement still looks the same. So we actually have fewer than 4 factorial different ways. We could actually write that in here. I didn't write it in. This is just 4 factorial. We have fewer than 4 factorial different ways to arrange the word fill. And in fact, for every one of these L's, or arrangements with the L's here, if we think about 4 factorial ways of arranging the letters in the word fill, for every one of those arrangements, we could swap the 2 L's. No matter where they are, we could swap those 2 L's and get the same word. So we need to take those arrangements out. And in fact, what we're doing is we're looking at how many different arrangements are there of these L's, and we want to divide by that many because we've counted those as separate words. So in this case, what we would end up with is 4 factorial different ways. But then we would have to divide by 2 because we can, for every arrangement, we've counted the word with the swapping of the L twice. And we can do the same thing down here with this sort of non-word, F followed by 3 L's. And again, now we have 3 L's. And I'm going to number them so that we can keep track of them. For every one of the arrangements like this, how many different arrangements do we have of these 3 L's? Well, there are 3 factorial ways to arrange those 3 L's. So if we want to figure out the number of arrangements that are in we can make up the letters F, L, L, and L, there are 4 factorial ways that we can arrange 4 letters, but we need to divide out all of the arrangements where we can swap the L's and still get the same number of words. Well, there are 3 factorial ways that we can do this. So again, 4 factorial is still 24. 3 factorial is 3 times 2 times 1. 3 times 2 is just 6. So it turns out that there are only 4 possible arrangements of the letters F, L, L, and L. And you can probably find those 4 possible arrangements. Same sort of thing here with 4 L's now. If we put an L in each one of these locations, we can swap those 4 L's around, and no matter where we move the L's, we still get the arrangement L, 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 and L. Continuing with the pattern that we've seen so far, the number of arrangements that we can make with 4 L's is equal to 4 factorial divided by the number of arrangements of these similar letters. So there are 4 of them altogether. 4 factorial divided by 4 factorial. That's the same as 24 over 24, or just realizing that a number divided by itself generally equals 1. So there we have it. Different arrangements of letters. And obviously this one is easy to find. We can see that this is the only possible arrangement of 4 L's. So let's look now at how do we write this out generally speaking. So generally speaking, the number of permutations of n objects where A are alike, another b are alike, and so on, is n factorial, where n is the total number of objects. So we'll call this the total number of objects. And A, B, and C are objects that could be different where there are multiples of each. And this kind of pattern continues on. I've listed A, B, and C there, but we could have any number of repeated letters, numbers, items, whatever you want to call them. So here's an example. Again, sticking with that arrangement of letters and words, how many ways can the letters of the word minimum be organized? Well, according to what we just talked about up here, we should be able to count the total number of letters. 1, 2, 3, 4, 5, 6, 7 letters in total. So if they were all different, there would be 7 factorial ways to organize those letters. But we have some duplication. We have, let's see, 1, 2, and 3 M's. So we need to divide out the number of ways that the M's can be swapped around. What else do we have repetition of? We've got an I here and an I here, so there are 2 I's there. And I think that's probably all of the repetition that we have. There are no duplicate N's, no duplicate U's, so that's as far as we need to go there. So now we just need to work out what 7 factorial is. So 7 factorial works out to 5,040. 3 factorial is 3 times 2 times 1, which is 6. And 2 factorial is 2. And I'm sort of running out of room here. So that's 5,040 divided by 12. And we'll just finish up over here. And we get an answer of 420. This means that there are 420 arrangements. Technically, there are different arrangements. Of the word minimum. So that's how we can deal with duplicate objects or dealing with identical objects.